Hi everyone, welcome to this short training video which is going to cover BCRL and its role in automated compliance checking. It's going to be presented by myself, Tom Beach, I'm from Cardiff University, and my colleagues Gonçal from the Salle University and Pasi from Solibri. Firstly, I'm going to give you a quick introduction as to what BCRL is. BCRL, which stands for the Building Compliance Rule Language, is a format used to represent digitised construction regulations. It's been developed as part of the ACCORD project. Essentially, it makes construction regulations machine readable. It contains all the human readable text as well as machine readable annotations to make the regulations executable as part of an automated compliance checking process. The BCRL format is designed to be utilised by regulatory bodies to digitise their regulations. So it's the people who issue the regulations that should be using this format. And we have developed several software tools to support regulatory bodies in doing this. It can be used on any regulatory document, but is designed specifically with construction regulations in mind. In this next section of the recording, I'm going to give you a brief introduction to what BCRL is. So BCRL is a YAML LD or JSON LD format. And what this means is these documents are linked data. And what this means is BCRL contains linked data. It's built on the semantics of the AEC 3PO ontology, and you can find out more about that by following this GitHub link. Their purpose is to formalise the structure of construction regulations in a semantic way. As I mentioned previously, they contain all the human readable text of the regulations, as well as their structure like paragraphs, sections, subsections, cross-references, etc., as well as machine readable annotations to make the regulations executable as part of an automated compliance checking process. This is an example of the structure of BCRL. This particular form is not designed to be edited or viewed by humans. This is a raw machine readable format. And what this is showing is how regulations are divided into parts, sections and subsections, with the text of these arranged logically fitting in with that structure. In addition to the text, as I said, we also insert machine readable annotations to enable these to be executed. Now, these machine readable annotations are done following the RASE methodology. Now, the RASE methodology has been widely adopted in automated compliance checking for several years. And this is an example of a RASE tagged regulation. And what essentially RASE is about colouring sections of the text, boxes in other words, as well as individual words in various different colours. And the colours specify whether something is a requirement, which is blue, an applicability, which is green, a selection, which is the purple, or an exception, which is the orange and yellow colour. And that comes together to stand for RASE, requirement, application, selection, exception. And by identifying each key word in one of these colours, we are identifying that that word indicates a decision point within the regulations. So having something in a colour indicates that something is a decision point. The colour that you choose, i.e. green, blue, etc., indicates how that particular decision point interacts with other decision points in that box. Okay? And an example of this here that's really simple is if we look here, we have the green word passageway, which is an applicability. We also have the green word building, which is an applicability. Okay. And what this means, this regulation has two applicabilities that must be met for it to be applicable. The first is that the thing we are considering is a passageway. The second is that that passageway leads to a building. It's impossible to go fully into the details of RASE in the few minutes that I have, but the really important thing to remember about RASE is it is about identifying whether something is applicable or not, and then if it is applicable, making a decision based on it. Think of a classic example. All doors must be 1 metre wide. The applicability is the thing must be a door. If the thing's not a door, we don't care about its width in the context of this piece of regulatory text. But if it is a door, we need to check it's at least 1 metre wide. And what that must mean is that in order for something to be in scope, we have these four colours that come together. So the first is the easiest to understand, the application. Something must be applicable. If it's not applicable, then we don't need to worry about it. Something must be selected, and selected is a way of making an applicability more detailed. So let's say all red or green doors. So the applicability is the door, the red or green is the selection, selecting from within that applicability. So something must be applicable and selected. It also must not be excepted. And what that means is we can specify exceptions to the rules. All red or green doors that are not on the ground floor. So if something isn't a door, this paragraph I've just said is not applicable. If something isn't red or green, it's not applicable. Equally, if the exception applies is not on the ground floor, it's not applicable. But if all of those things do apply, if we are a red or green door on the ground floor, then we must check if it meets the requirements, and that is the blue element of RASE. Once we understand what RASE means, we can drill down into the next level of detail. And this is about specifying what each of the words that we highlighted in the previous step means. And often this is just a very simple comparison. And in BCRL we simplify this into some simple expressions, and we provide an editing tool to help people make use of these expressions. The first few are very simple. So we could say what this decision actually means is we're checking if something is external. So we're saying, is it external? True. So checking if a particular part of the building is inside. The most common type of comparisons are using things like greater than or less than operators. So here we might say the width must be greater than 1.2 metres. We also might check the type of an object. Is the type a house? It might have something like a usage category. So a usage category might be something that's defined by a given regulation, and say something like, oh, my usage category might be 4. In this case, my usage category might be domestic. My usage category might be leisure. Many construction regulations define things like usage categories or usages, and they have their own specific sets of values that these can be within each kind of legislative structure. One of the things we did in ACCORD, and we don't have the time to go into this in detail in this short video, is to provide support for first order logic as well. Because a vast majority of construction regulations make use of first order logic. And these are things like this particular example on the next row is to see if a given object that has an external wall. So let's say we're thinking about particular spaces, so it might be all rooms that have an external wall. And that might trigger a different applicability to if a room doesn't have an external wall. So we not only want to be able to check things about a given object, we might be able to check things that the object touches or connects to, etc. And these expressions allow us to do this. And one of the things that we'll be doing is providing a visual code editor to allow people to make use of these expressions. I'm now going to pass over to my colleague Gonçal Costa, who is going to showcase our tools that we've developed for BCRL.
The creation of BCRL documents is part of the regulation formalization process designed in the ACCORD project. This process can be performed through a tool developed within the project called Rule Formalisation tool. The following diagram shows how the process is carried out using the tool. The part framed in red is where the BCRL expressions are defined. As can be seen, the process begins with the definition of a project to transform a regulation from a PDF format into a machine executable document. After providing the basic metadata, like regulation name, the country, the scope, etc., the PDF document of the regulation provided by the user is transformed into text format and displayed in the web viewer with a similar appearance as it would in any other PDF viewer. The first step user must take is to identify the sections of the regulatory text using a tool for this purpose provided in the viewer. Within each section, the user must apply the RASE method to tag and structure the clauses in a hierarchical order. Within clauses, a user can identify sections where BCRL expressions can be associated. As this part of the process is complete, the tool provides a view showing only all BCRL expressions, so the user can see if any of them have an error, no a syntax error, as this is checked in real time, but an error in what they actually define. If all expressions are correct, the next step is to generate the machine executable document and then submit it to the public rule database. To see how this process is carried out in a real case, the following part shows an example of how BCRL expressions are defined for a fragment of the Finnish accessibility regulation using the tool. Anti-regulation digitalization project has been created and the corresponding PDF of the regulations has been uploaded by the user, in this example case the Finnish accessibility regulations. The next step in the process is to access the annotation interface. The first thing to do is defining the sections, then annotate the regulatory text by applying the RASE method. The interface provides 8 buttons that allow the user to do so. 4 to define the clauses and subclauses according to whether they refer to a requirement, application, section or exception, and 4 more to select parts of the text based on these same categories to define objects, properties, or reference to other parts of the text of the regulation or to another documents. To carry out the specific tagging as part of the RASE process, some additional functionalities are provided to create expressions in BCRL language. After selecting the text and click on one of the RASE buttons, a panel appears offering 3 main options for the user to choose from: object, property or reference. Property option will be selected when users want to indicate that the selected regulatory text refers to a property. References option will be selected when there are situations in regulatory text where some articles or clauses refer to other parts of the text, where it is a specific piece of information, a clause, or entire section. In the example we are seeing on the screen, there is a clause of the Finnish accessibility regulation related to the minimum width of a passage leading to a building. In this case, the tool has a feature that allows it to detect its corresponding part of the BCRL expression. Expert users can choose to view the generated code and edit it. When finished with the RASE tagging, the next step is to review and validate the BCRL expressions. After that, the tool will then generate 2 files that will include the regulation formalized as a knowledge graph. The first is the one that is intended to be stored in the public rule database. The second provides a better view for humans to identify how the knowledge has been structured. Finally, the resulting machine executable document is published in the public rule database. I will now pass you back to Tom Beach, who will describe the next section.
Next, I'm going to give a short example of how this orchestration works based on one of our demo cases. And we're only going to consider this one short piece of text with just 2 decision points. These 2 decision points are cross-section, so testing if a given thing inside the building is a cross-section, and this formula here, which defines if it meets one of the structural requirements in Eurocode 6. And when implemented, the orchestration with BCRL looks something like this. We have our orchestration component here on the left-hand side, and this component is responsible for parsing the BCRL, understanding the structure of it. And it will understand that there is 2 decision points here. One is an applicability and one is a requirement. It will identify that it needs to look at the applicability first. So it sends a message to the microservice asking it to check the type of various objects in the model file to see if they're cross-sections. The microservice will do that and it will return a list of cross-sections to the orchestrator. The orchestrator now knows which objects in that model are applicable and which are not. So it can get rid of all the non-applicable objects, we don't need to worry about them anymore, and all it's left with now is the cross-sections. For these cross-sections, it will then take this formula, which is really a division sum between 2 different variables, and pass it to the microservice. This microservice is designed to make these sort of structural calculations, so it understands that the request has been sent. It will make the structural calculation and then return a true or false value for every cross-section that it gets asked about. So there may well be, say, 20 cross-sections in this particular building. This message will be sent along with a list of these cross-sections to the microservice. The microservice will make the calculation and then return a list of true or falses for each cross-section as to whether they comply with this particular structural calculation. If they do comply, then it implies everything is great. If not, then the orchestrator will be able to produce a sensible error message that can be fed into the wider compliance checking process. I'm now going to pass over to my colleague Pasi, who's going to show you specifically how this sort of approach would work in the Solibri software.
Here is the Finnish accessibility building code as BCRL in all its glory. As you can see, this is not meant for human consumption, but a computer can understand and evaluate. In Solibri, we have developed a new rule that can evaluate BCRL. We also have a tool that converts BCRL to Solibri rule set. The rule set will have one rule per BCRL chapter. It is possible to run the BCRL in Solibri desktop. Here you can see the accessibility code results. Here you find a ramp that has a slightly too high gradient. And here is a door whose landing is not large enough. BCR rule can also be run in Lukapiste by Cloud Permit. In the background, Lukapiste uses Solibri's checking as a service platform to run the rules. Here you can see the same rules evaluated in Lukapiste.
Thank you for watching. If you have any queries, you can follow the QR codes here to get more information.